Today we are, as I said, taking a break away from Eureka Math, and we are going to be focusing and using the Go Math book for just a couple lessons, okay? And so instead of giving you the workbooks, I've made copies that you will need. So you're going to put this into your workbook, and it's a packet that you're going to be using for the next couple days, this week and next week. Make sense? Today our learning goal says I can identify and classify polygons. Identify means when I see a polygon, I can name what it is. And classify, we know from science, what does it mean to classify something? Everyone? To sort it, yeah, so we can sort them based on their properties. Very good. But before we get into that, let's do a little bit of a review and talk about our problem of the day. This question, as we talked about, is very similar to what you saw in your weekly check-in last week, and it will also be on your weekly check-in this week. We're being asked to find the area of the square. And we know that the perimeter is 46 inches. So if we draw a picture, a square would look like that. Yes? What do we need to know in order to find the area? We need to know what the length is and what the width is. Do you agree? What do we know about squares? What's one property of squares that we know? Luke? All sides are equal. So in this case, would the length and the width be the same? Very good. The question tells us that the perimeter is 46 inches. What does perimeter mean? Brian? The distance around, so if I start here, the perimeter is this, plus this, plus this, plus this. But as Luke told us, all the sides are equal, right? So we could call our sides S for side. S, 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 S. They're all the same sides, right? So if I do S plus S plus S plus S, what do I get? 46. So is that another way to say 4 times S? 4 copies of S would be 46. So how can I find the length of one side? 46 divided by? 4. Very good. 46 divided by 4. When I do that, what do I get when I simplify that improper fraction? How many holes are there? How many fourths does it take to make one hole? 4. So how many fourths are there in 46? 11. Good. How many fourths did I use up to make 11 holes? 44. 44. So how many are left? 2 fourths. How do I write that in simplest form? 11. Very good. So is that my final answer, 11 and a half? No. That just tells me that each side, now instead of S, we know that each side is 11 and a half what? Inches. Very good. Now, how can I find the area then? Well, I know the area is the length times the width, right? So what's the length? 11 and a half. What's the width? So I can find the area by doing 11 and a half times 11 and a half. Am I ready to multiply? No. Because I have mixed numbers. Some of us are mistakenly multiplying 11 times 11 and then 1/2 times 1/2. Is that correct? No, because I'm not distributing. I have to multiply 11 by 11 and then 11 by 1/2. Then I have to multiply 1/2 by 11 and 1/2 by 1/2. See how I have to make all the possible pairs? That's the same as doing what? An area model. Good. Do you think the numbers will be big or small when I have 11 and 1/2? Pretty big. So what is the better strategy to use? Very good. If you haven't yet, go ahead and set up an area model. It says the Castel del Monte in Apulia, Italy, was built more than 750 years ago. The fortress has one central building with 8 surrounding towers. So if you look at the picture, do you see how there's one main building and then 8 of these little towers around it? Do you see that? The question asks, which polygon do you see repeated in the structure? How many sides, angles, and vertices does this polygon have? Okay. Some of us might already have some knowledge about what polygon this is. Some of us might not. We're going to talk about it. We're going to come back to this in just a moment. If we keep looking down the page, it says a polygon is a closed plane figure formed by 3 or more line segments. Let's take a look and analyze that for a second. Everyone say polygon. Polygon. That is your vocabulary word, okay? It's a closed plane figure. Plane means 2-dimensional. Okay, so you might want to write, that means 2D. So is this container a polygon? Because how many dimensions does this container have? 3. Okay, so it has to be a 2-dimensional figure. Let me write that a little more neatly. 2D figure. Closed means it can't be open. So is that a polygon? No. Why not? It's not closed. Okay. What about that? Is that a polygon? Yes, because it's closed. Okay. And it's formed by 3 or more line segments. So 1, 2, 3, 4. Is that a polygon? Yes. Is this a polygon? 1, 2.
No.
Why is that not a polygon? Aradna? It's not closed and it only has 2 line segments. What about this? 1, 2, 3. Has 3 line segments. Is that a polygon?
No.
Why not? It's not closed. Okay, what about this one?
No.
Is it closed? Is it made up of 3 or more line segments?
No.
This portion right here, is this a line?
No.
So, is that a line? No. I know in art we learned that lines can be curved, but in math lines are always straight. Does that make sense? So is that yellow highlighted portion a line?
No.
So is that a polygon? No. This is not a polygon because it is not made up of 3 or more line segments. A curve in math is not a line. Okay, so that's a distinction you have to know between art lines and math lines. And math lines are ongoing straight lines that never end. Make sense? Line segments are lines that have ends. Okay? So is this a polygon? No. Okay. So we know that polygons are made up of 3 or more line segments that meet at points. So actually, before we go talk about the vertices, in your blank space on the side right here, please draw yourself a polygon. This is an example of a polygon because it's made up of line segments, it's closed, and it's a 2D figure. Now the line segments meet at points called vertices. So here's a vertice because 2 lines meet, here's a vertice, 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 and here's a vertice. Go ahead and circle your vertices. Polygons are named for the number of sides and angles it has. An angle is what's formed here by the 2 line segments. So this right here, this part right here, that's an angle. Do you see that? Okay, so we write angle, angles are marked like this, with a curved line connecting the 2 line segments. Go ahead and show all the angles inside of your own polygon. Now, polygons are named based on how many the number of sides and angles it has. Okay, so look at the table below. If a polygon has 3 sides, what do we call it? Okay, so look in the picture of the triangle. How many vertices does it have? Okay, fill it in. Remember I said vertices. How many angles does it have? In the picture of the triangle they provided you, circle the vertices. And then show the angles with your curved lines. So you'll see 3 vertices, 3 sides, and 3 angles. Very good. Go ahead and complete the chart by circling all the vertices and showing the angles and counting how many there are for each of those figures. Go. So what do we call polygons that have 4 sides, 4 angles, and 4 vertices? Everyone say quadrilateral. Very good. We call polygons that have 5 sides, 5 angles, and 5 vertices pentagons. Everyone say pentagon.
Pentagon.
We call polygons that have 6 sides, 6 angles, and 6 vertices hexagon. Everyone say hexagon.
Hexagon.
As you're circling the vertices and marking the angles, are you seeing that it always matches the number of sides? Very good. Complete this work for the heptagon, octagon, nonagon, and decagon. Based on what we now know about naming polygons, what is the polygon that's repeated over and over again in this beautiful Italian castle? Everyone? Octagon. How do you know it's an octagon? Because it has 8 sides, 8 angles, and 8 vertices. Please draw a line to show one of the sides of an octagon like that. All right, let's draw 2 line segments. The 2 line segments make it one of the vertices, and of course they also make an angle. Do you see that? Good. Now that you know the different polygon names, you need to know that there are special polygons called regular polygons. It doesn't mean that they're more normal or more boring and they're not as special. In fact, they're more special. Regular polygons are polygons that have the same angles. All the angles are the same length or same angle, and all the sides are the same length. Okay? Another word, we've learned that equivalent means same, right? But another word that means the same in math is congruent. Everyone say congruent. Congruent means equal. Okay, so go ahead and write that in your notes. 2 polygons are congruent when they have the same size and the same shape. In a regular polygon, all sides are congruent and all angles are congruent. Now, here in this, what is this polygon right here? What do we call it? How do we know it's a pentagon? Because it has five what? 5 sides, 5 vertices, and 5. Good. Now, you can see how long is each side? 4 centimeters. They labeled it. 4 centimeters, 4 centimeters, 4 centimeters, 4 centimeters, and 4 centimeters. How big is each angle? 108 degrees, 108 degrees, 108 degrees, 108 degrees. They labeled it. So we can see that all sides are congruent and all angles are congruent. What this means is that this is a regular, be more specific, it's not just a regular polygon, it's a regular pentagon. Good. Go ahead and write that in your notes. Now, when we're drawing polygons, if I were to draw this pentagon, it might be hard to make sure, if I don't take out a ruler, that all sides are equal, right? Or that all angles are equal, right? So we can use markings. We can write measurements to show. We could write the measurements just like they did, but we can also use markings. If I draw one tick mark like this through each side that has that same symbol, that same tick mark, I know that that means it's equal. If I draw 2 tick marks through that one, but the rest all have 1, that means these 4 are equal, but this one is different. Do you see that? Okay. Same thing with the angles. I'm going to make it into a regular one again. If I draw the same 1-line angle marking, that shows that all 5 of those angles are what? Equal. What's the mathematical word that we just learned? They're all congruent. But if I draw this one as a double angle line and this one as a triple, right? It shows that these 3 down here are congruent, but these 2 are different. Do you see that? In fact, are these 2 the same as each other? No, they're different. Okay, so you have 2 ways to show that angles and sides are congruent. You can either write the measurements or you can use markings. Make sense? In your notebook right now, and by notebook I mean the white space, I want you to draw a quadrilateral and use markings to show that it is a regular quadrilateral. Go. If you look at this one right here, this is not a regular polygon. Not all sides are congruent. Not all angles are congruent. You can use the same markings to show that some sides are congruent and some angles are congruent. In this pentagon right here, can you find 2 sides that are congruent? Go ahead and draw or circle the 2 sides that are congruent. These 2 are congruent with each other, right? Or these 2 are congruent with each other. Do you see that? Because how do you know that those pairs are congruent? Talk at your table groups.